So this video follows along with a few questions from your 5.1 worksheet for day 2 and day 3. So you are responsible for completing the front side that is titled day 2. We're going to go over numbers. I'm going to go over number 5 and number 13 with you, and then I'll do a few from the back side as well. But you're responsible for making sure the front and the back is complete, as well as the problems listed at the bottom of the back side. And I'll go over that in just a second. So sometimes when you simplify these trig functions or trig equations, expressions, you may have to multiply or factor or things like that. So in this specific example in number 5, you've got two binomials that are being multiplied together. So what you want to do is you want to do your double distribution. So you want to do secant times secant, which would give us secant squared of x. Then do secant times your 1, which would just be plus secant of x. Then distribute the negative 1, so that's going to be a negative secant of x, and then negative 1 times 1 is a negative 1. So you'll notice that your terms in the middle cancel out, and that leaves you with secant squared of x minus 1. Well, that looks similar to one of our trig identities. We have a trig identity that deals with secant squared, but it is written as tangent squared of theta plus 1 equals secant squared of theta. Well, if we subtract 1 on both sides, that gives us tangent squared of theta equals secant squared of theta minus 1. So that means that this secant squared of x minus 1, I can replace that with tangent squared of x, and you are finished. You have used your trig identities to simplify what was a binomial being multiplied by a binomial down to just a trig function tangent squared x. Notice we couldn't go straight there because the first two binomials do not have squares in them, and then one's a plus and one's a minus, so you had to actually multiply it out. All right, the next one I want to talk to you about is number 13. This is kind of a prereq into what we're going to start on Monday, which is proving these identities. So we've seen some like this before back in section 4.3. So you want to rearrange one side or the other to make it match the left side. In general, y'all, what you want to do is you want to deal with the complicated side first. So you want to deal with the harder side. So that way, hopefully, you can rearrange the harder side to match the easy side. So the first thing we can do here is we can rewrite this as cotangent of theta divided by cotangent of theta plus tangent of theta divided by cotangent of theta. And we are trying to see if that does in fact equal secant squared of theta. Well, cotangent divided by cotangent is just 1. And like we discussed on Monday, we want to write this instead of as a fraction, we want to write that as a product. So tangent of theta times 1 over cotangent of theta. Well, 1 over cotangent is simply just tangent. So that's really tangent of theta times tangent of theta. And if you have tangent of theta times tangent of theta, that is 1 plus tangent squared of theta. Then we can remember that our same trig identity from earlier, from number 5, tangent squared of theta plus 1 equals secant squared. So that gives us our final answer that we need, secant squared equals secant squared. Once you get equivalencies on both sides, you are finished. So anytime you are asked to verify or transform one side to the other, you want to deal with the harder side, the more complicated side first. So after you finish watching this video, I want you to finish completing 1 through 13 using your trig identities and simplify them and rewrite them. And what we're going to look at next is on the back side, we're going to look at number 1. So looking at number 1 there. We're going to have to review factoring before we can finish this one out. So when I look at this, this is of the form x to the 4th minus 2x squared plus 1. Because if I look at that, if I take those cosecants of x and I, kind of ignore them, that's in that general form. Well, that is in the general form of x squared minus 2x plus 1. So all we have to do is we've got to remember how to factor that. Now you may have learned how to factor differently, so just however you would normally factor it. Remember that we need to multiply times to your a times your c, which in this case is 1, add to your b, which in this case is negative 2. So no matter which one of these you're factoring, you've got your minus 1 and your minus 1 because negative times a negative is a positive, and when we add those, it's a negative 2. So I could write this instead of as x and x, instead of having an x minus 1 and an x minus 1, it would be x squared minus 1 and x squared minus 1. Well, I'm going to use this and instead factor it with my cosecants in there. It looks the same. You have your cosecant squared x minus 1 times cosecant squared x minus 1. Once you've done that, hopefully you are starting to be able to recognize these trig identities, and that trig identity you can use 1 plus cotangent squared of theta equals cosecant squared of theta. If I rearrange this and I subtract 1 on both sides, that gives me that cotangent squared of theta is cosecant squared of theta minus 1. So that means each of these binomials can be replaced with cotangent squared of theta, or x in this case. And in your exponent rules, when you multiply those together, that's just cotangent to the 4th of x. So that trinomial can be factored. You can think of it as using trig substitution, where we just let x, so in this case we let x equal cosecant of x to write it, and then you've got to remember how to factor a trinomial. All right, the next one I want to look at is number 2. Now this one can be completed in 2 different ways. I'm going to show you using factoring, and then I'll show you just using your trig identities. It doesn't matter which one you want to use. It just depends on what you see better. When I was working this, I recognized that they both had a cosecant squared in them. So I factored out a cosecant of x, or cosecant squared of x, and so that left me with 1 minus cosine squared of x. Well, 1 minus cosine squared, remember sine squared plus cosine squared equals 1. So that means 1 minus cosine squared is just sine squared. I'm sorry, I need an x there instead of a theta. And then you can rewrite this cosecant squared as 1 over sine squared. Your sine squareds cancel out, and you're left with just 1. Or option 2, some students don't recognize the factoring, which is totally fine. You do not have to necessarily recognize that factoring. Some students want to rewrite this with your signs in there. So you could rewrite this as 1 over sine squared of x minus 1 over sine squared of x times cosine squared of x. Well, cosine over sine, you would just have 1 minus sine squared of x minus cosine squared of x over sine squared of x. Those have common denominators, so we can write this as 1 minus cosine squared. Then that same trig identity, you can replace that with sine squared of x, and then divide it by sine squared of x, and you still end up with the outcome of 1. So it doesn't matter which method you use. It doesn't matter how you go about it, as long as you use equivalencies of either factoring, your identities, things like that, in order to rewrite these. All right, so one thing I do want to mention is in number 4, as you work this one out, you have secant to the 4th of x minus tangent to the 4th of x. I'm going to give you a hint to do this. You're going to use difference of squares to factor it. And then I'm also going to tell you that your answer is going to have 2 different trig functions in it, okay? So you cannot get this one down to just 1 trig function. Your answer has 2 trig functions in it. So once you get down to that, you're done. This one you can actually not simplify down any more than what you get once you factor using your difference of squares and replace one of those. So your practice work for the rest of the class period is I want you to make sure that you complete the front side. So complete the day 2 practice and the day 3 practice. And then the second thing, your homework for today is on page 357. The bottom of day 3 tells you to do 59 and 60, but I do not want you to do 59 and 60. I just want you to do those 47, 48, 51, and 52.